friends. Myself CL Pawar, teacher in physics. We have seen the topic electricity. In electricity, Wheatstone's meter bridge, Wheatstone's network, Kelvin's method, post office box, and now we have to study Wheatstone's bridge for strain measurement. Strain measurement, there is strain gauge. With the help of this strain gauge, we measure the strain. Now in this Wheatstone's bridge, there are resistances A, R1, R2. Third resistance is variable, and instead of unknown resistance, we have to connect the strain gauge. The cell is connected between A and C through the plug key. Between B and D, we measure the potential difference. Now when there is no strain, there is no force, therefore there is no strain, current is passed. The variable resistance R3 is so adjusted that there is no current through the voltmeter. There is no potential difference across the voltmeter. That means this network is balanced. Strain gauge is 0. Now strain is applied. That means force is applied, strain increases, force is reduced, strain decreases. Increase or decrease in the strain gauge causes the difference in potential difference, which is measured across this BD with the help of voltmeter. When strain is large, then voltmeter shows large deflection. When strain is small, then it shows less deflection. When there is no strain, there is no potential difference. That means bridge is balanced. This strain is proportional to the resistance. Resistance is large, strain is large. Resistance is small, strain is small. Thus, the strain gauge which produces strain, that is measured with the help of this Wheatstone's bridge. So this is one of the applications of this Wheatstone's bridge. That means we measure the unknown resistance by Wheatstone's bridge. We measure resistance of galvanometer by Kelvin's method. Here we use post office box for measurement of unknown resistance, and similarly we have to measure the strain. We use this Wheatstone's bridge. Now in a meter bridge, when we perform the experiment, there are some errors, sources of errors. Now first error, if wire is not uniform. The wire usually in meter bridge is not uniform, then there may occur an error, because the resistance is directly proportional to length of the wire. So wire is not uniform, therefore there is error. Second, at the ends A and C in meter bridge, there is contact between metal strip and that wire. So contact resistances are developed, and due to these contact resistances, some error is in measurement of the reading. So this is another error. Third, we measure the lengths. For measuring lengths, there may be some defect, some error. Therefore, the another error is also there. Fourth, when wires connect, the contact is loose, then again there is error. So these are the sources of error in Wheaton's meter bridge. Now, how to minimize these errors? These errors are minimized in different way. If the wire is taken is uniform, then the error is eliminated. Secondly, the null point is obtained on the wire. That null point should be near about the center. Then percentage error is reduced. Third, the readings are taken by interchanging the positions of resistance box and unknown resistance. If we interchange, the error is minimized. Fourth, the connection should be very tight, then error is minimized. Fifth, the jockey is touched to the wire. It is not sliding on the wire. It should touch at different points, and point of contact is obtained so that the galvanometer shows null deflection. So that error is also minimized. Readings are taken, number of readings are taken. When readings are large in number, taken in large in number, then error is minimized. Like this, the errors in meter bridge, these are minimized. So sources of errors and their minimization can be done in this way.